Hello students, welcome to IMS Academy. But in the foundation course, I started electronic devices and circuits. This is part 10. The semiconductor topic I started with 10 videos, 9 videos completed so far. This is the 10th video. But in this topic, I did already insulators, conductors, semiconductors, energy band diagrams of all these materials I have drawn. And also I explained about the theory and analysis also done wherever it is required. And also I did number of gate questions. Even in this session, in the last session, I explained compensated semiconductor. But I want to give the formula related to the compensated semiconductor, and I wish to do certain number of the problems also. Understand now? And also we can do today diffusion and Einstein relationship, problems related to them, we can do them now. Understand? Before entering into the subjects, you should know some information regarding the IMS GATE Academy. The students who wants to take admission for GATE 2025 and 2026, they can take admission in, the students who wants to take the admission, who wants to take the GATE coaching, can make a call to these numbers. Students who wants to take the admission in IMS GATE Academy, they can make a call to these numbers. They will get the required information from the people belongs to the IMS GATE Academy. And what are the program features of this IMS GATE Academy? IMS GATE Academy provides more than 800 hours of live classes with live interaction. The IMS GATE Academy provides theory book, exercise book. The exercise book contains more than 4,000 questions. It contains level 1, level 2 and level 3 questions. But these are all the problems. If you practice, it is quite okay to crack the gauge. But along with this 4,000 plus questions, you will receive 34 plus years of the GATE question banks with video solutions. That means IMS GATE Academy provides more than 34 years GATE question banks with video solution. Every one of the GATE question was done. For certain questions, alternative solution also given. For certain questions, video solutions also given. And for certain questions, keynotes also given. 12 personalized one-to-one mentorship sessions possible. Because of these mentorship session, the students can directly discuss with the faculty. And they can get the advice from the mentor, how to prepare for the GATE, what are the topics are to be started initially. That means the proper study plan will be given by the mentor to the students. More than 130 online tests with video solutions of the mock tests and many more possible. Without delay, you take an admission. If you want to get any information, you call to these numbers. Stand now. Now we can enter into the subjects. In the last class, I explained what is a graded semiconductor. What I explained? So not graded, compensated semiconductor. What is compensated semiconductor? I explained. What is compensated semiconductor? If the semiconductor is doped with pentavalent and trivalent atoms, then it is said to be compensated semiconductor. In case ND value, ND means donor concentration, ND value is greater than NC, ND value is greater than NA, NA means acceptors concentration, ND is the donor concentration. If ND is, I am writing here now, if ND is greater than NA value, NA is the acceptors concentration, ND is the donor concentration. Then the compensated semiconductor can act as an N-type semiconductor. already I said the compensated semiconductor can act as N-type extrinsic semiconductor. That's possible. I say you have taken intrinsic semiconductor, there more concentration of donor atoms are made as compared to the acceptors concentration. At the time it is said to be N-type extrinsic semiconductors. The concentration of electrons in this material is calculated by N equal to Nd minus Na, plus under root of Nd minus Na whole square, plus 4Ni square divided by 2, whole divided by 2. The formula is generally used. Nd minus Na plus Nd minus Na whole square plus 4Ni square by 2. The formula is generally used. Already I did in N-type extrinsic semiconductor. N equal to Nd plus under root of Nd square plus 4Ni square whole divided by 2 I gave it. Wherever Nd is given, there we are using Nd minus Na. This way we can find concentration of electrons. What about the minority carriers? How we can determine the hole's concentration? The whole concentration is calculated by mass action law. Mass action law is nothing but Ni square by N. By using this formula, you can determine concentration of holes. Electrons you can get from here. This formula you can use. But what about the conductivity? By using what formula you can find out the conductivity? Conductivity is denoted by a letter conductivity. In this compensated semiconductor is calculated like this. It is given by symbol sigma. Conductivity due to electrons, conductivity due to holes. We need to put. Conductivity due to electrons, you know, N into Q into mu N, you know very well. Conductivity N we know, we are going to get by using this formula. The Q means charge of electron, mu N is nothing but mobility of electron. Sigma P is calculated by P into Q into mu P you can use. The P is nothing but the concentration of holes. The whole concentration we got already by using mass action law. That value we can substitute. Q is the charge, mu P is nothing but the mobility of holes. This formula we need to use. We need to use this formula here. This formula is to be used here now. This is one more formula, we can say that. So we are getting the conductivity also. What about current density? How we can determine current density in this compensated semiconductor? Current density means you know very well. Current density is nothing but the J. J equal to what is the formula? Sigma into E already given. Sigma is nothing but the conductivity you will get from this formula. E is nothing but the electric field intensity. By multiplying these two you can get the current density. Current density you know amperes per cm square or amperes per volt square you can say that. Sorry, amperes per meter square also we can put it now instead now. This is the formula required. This is one more formula. Now using this formula we can find Sorry, this is one of the condition. If ND is greater than NA, this formula we need to use. In case if NA is greater than ND, then the given compensated semiconductor can act as a p-type extrinsic semiconductor. If ND is greater than NA, the compensated semiconductor can act as n-type semiconductor, I said now. If I can write, if NA is greater than ND value, this condition is satisfied, then compensated semiconductor can act as p-type extrinsic semiconductor. P-type extrinsic semiconductor, p-type semiconductor. Already we said that is a n-type extrinsic n-type semiconductor. Otherwise you can write now p-type semiconductor is enough. Or p-type extrinsic semiconductor or p-type semiconductor. We can write like this now. But in this case, the majority carriers are nothing but holes. Minority carriers are nothing but electrons. But how we can determine majority carriers of holes? That is more important. That is calculated by the formula. By using this formula, you can find holes can be calculated by Na minus Nd. Na, capital A or small a, your wish, no problem. Na minus Nd plus under root of Na minus Nd. If you want capital A also, you put Na minus Nd whole square plus 4Ni square divided by 2. You should use this formula. Na minus Nd plus Na minus Nd whole square plus 4Ni square. The formula is required to find out the majority carriers of the holes in this compensated semiconductor. You can use this. This is one more formula. Yes, this is one of the formula. The next formula. But majority carriers we are going to get by using this formula. What about the minority carriers? Minority carriers in this compensated semiconductor are holes, you know very well. Sorry, electrons, you know very well. The electrons concentration is minority. Minority carriers can be calculated by mass action law. So how we can find electrons concentration? By using the mass action law, Ni square by N. The formula you need to use to find out the results. This is one more formula you must remember. Sorry, concentration of the holes, not N. P you have to write there now. I have written the N. You must use their P. Ni square by P, because the P is nothing but the majority carriers only here now. This formula required. What about the conductivity? Conductivity is calculated by conductivity. Conductivity is nothing but sigma. You know very well conductivity, total conductivity is nothing but the conductivity due to electrons plus conductivity due to holes. This formula we must use. Sigma n I can get from the minority carriers. N into Q into mu n I can use the formula. Sigma p, the p into Q into mu p, you know very well. P into Q into mu p. Addition of these two will give the required value. Where N and P, you know, electrons concentration, and P is nothing but the holes concentration. So you must remember this formula also. This is one more formula. And the last and final formula is current density. How to find current density? In this p-type compensated semiconductor, that compensated semiconductor is acting as a p-type only now. So, current density is denoted by a letter J. J is calculated by sigma into E. This formula you must use. Sigma is nothing but the conductivity. Here the formula is given. E is the electric field intensity. So, you should mark up this formula also. These are all the formulas, very important, I say. So, I gave every formula. And one more condition I want to give here now. What is that condition? You please watch. But I gave here, if ND is greater than NA, the formula given here now. If NA is greater than ND, I gave it. If ND and NA are given equal, then the given compensated semiconductor can act as what? That is more important. I say if ND and ND donor concentration is equal to acceptor's concentration, both are equal. In this case, if ND is greater than equal to NA, the compensated semiconductor, can act as intrinsic semiconductor. I can write intrinsic semiconductor. The intrinsic semiconductor means you know very well, concentration of electrons equal to concentration of the holes equal to what? Ni. Ni equal to P equal to Ni only now. These are all equal. But already all the conditions are given in the anti-extrinsic semiconductor. Same conditions we can use only now. Anyhow, that formula is to be used. Now, I would like to give one problem based upon this. I want to give, by using this compensated semiconductor, I want to give one problem. A germanium sample is doped with 10 power 14 phosphorus atoms and here given and 7 into 10 power 13 boron atoms per cm cube. If here given, if Ni equal to 2.5 into 10 power 2.5 into 10 power 13 2.5 into 10 power 13 2.5 into 10 power 13 per cm cube is given. Here now. And the mobility of electrons mu n equal to here given, mu n equal to 4000 cm square per volt second is given. And the mu p is given here. Mu p is given 2000 cm square. 2000 cm square per volt second it is given. That much value given for mu p. But what is asking in the problem? Calculate carrier concentration, comma, and one more question he asked, carrier concentration, conductivity, is asking to find the conductivity, and current density in the sample, and current density in the sample. Is given. In the sample, if electric field of 20 volts per cm, here given, 20 volts per cm is applied. This is the given problem. How we can find this problem is more important. But how we can find this value? What is given in the problem? A germanium sample is doped with a 10 power 14 phosphorus atom. Phosphorus means, is it a pentavalent atom or trivalent atom? Phosphorus is a pentavalent atom. So this value will be 10 power 14 atoms per phosphorus atoms per cm cube, very important now, per cm cube. That many what this ND value is given in the problem. And 7 into 10 power 13 boron atoms per cm cube. Boron is a trivalent atom. So 7 into 10 power 13 is Na value. And Ni is given, mu N is given, mu P is given, is asking to calculate carrier concentration, conductivity and current density. So we can do one by one. But how this material connect? The compensated semiconductor only, no doubt, because addition of pentavalent and trivalent atoms are made. Both are made only now. But you should check in the problem, ND is greater than Na or Na is greater than ND or ND and Na are equal. We need to identify that point. Here it is given ND is nothing but, I can note down here now. Here given ND is nothing but 10 power 14 it is given. ND equal to 10 power 14 per cm cube I can put here now. And Na is given here. Na is nothing but 7 into 10 power 13 atoms per cm cube is given now. So ND is greater than Na value only here now. So at the time this compensated semiconductor can act as a n-type extrinsic semiconductor. If it is acting as a n-type extrinsic semiconductor, the majority carriers are nothing but electrons here now. The concentration of electrons determined by using this formula. What formula I gave already? Nd minus Na plus under root of Nd minus Na whole square plus 4Ni square by 2. The formula is given already. By using this formula, you can determine. Substitute every value and find its value. Nd value, Na value, all you can substitute here now. So N is required. Nd is given in the problem 10 power 14. Already given. Na is given. Na is nothing but Nd is given 10 power 14. Na is nothing but 7 into 10 power 13. 7 into 10 power 13 is given. Plus Nd minus Na. Nd is nothing but 10 power 14. Na is nothing but 7 into 10 power 13 whole square plus 4 Ni square. Ni is given in the problem 2.5 into 10 power 13. 2.5 into 10 power 13. 2.5 into 10 power 13. Ni square is given. This is square it. Whole divided by 2. Whole divided by 2 is possible. Use calculator. The finally concentration of electrons, you will get like this. N is 4.415 into 10 power 13 per cm cube is possible. So, this is the concentration of electrons you will get now. If there is any calculation mistake, you cross check it. Use calculator and find it now. Understand 4.415 into 10 power 13. I am getting here now. But what about concentration of holes? Because in the problem is asking concentration only now. Both concentrations required. The concentration of holes we can determine by using Ni square by what I gave it, N. Ni is nothing but already you got Ni 2.5 into 10 power 13 whole square divided by N. N is nothing but 4.415 into 10 power 13. Use calculator, you will get concentration of the holes. You will get this value as 1.415 into 10 power 13. 10 power 13 per cm cube is possible. This is the concentration of the holes. We are getting the both concentration now. And also in the problem is asking to find, is also asking to find what value? Carrier concentration is over. Conductivity also required. Here asking to find the conductivity. Yes, we can find the conductivity also. Conductivity is denoted by a symbol sigma. Conductivity equal to, I gave already formula, N into Q into mu N plus P into Q into mu P already given. And you can substitute N I got as 4.415 into 10 power 13. The charge, the value of the charge you know, 1.6 into 10 power minus 19 coulombs, you know very well. What about mobility of electrons? Mu n value is required here now. Mu n equal to 4000 here given. 4000 here given. 4000 plus P. Concentration of holes here we are getting 1.415 into 10 power 13 into Q. Q is nothing but 1.6 into 10 power minus 19, you know very well, into mu P. Mu P is nothing but the mobility of holes, already given in the problem. Mobility of holes 2000 here given. This is 2000. Use calculator, you will get sigma value. This value is 0.032. 0.032 mho per centimeter possible. Units are mho per centimeter. That is the conductivity. And also is asking to find what value? And also is asking to find current density. When electric field intensity equal to 20 volts per centimeter required. Current density is denoted by symbol J, you know very well. J equal to already I gave sigma into E. The sigma value we got already. What is sigma value? 0.032. 0.032. Electric field intensity is given here. Electric field intensity is given 20 volts per centimeter. 20 here given. Use calculator, you will get J value here directly. Finally, J value is 0.64 amperes per cm square possible. Amperes per cm square is possible. So, this is the solution for this question. So, one problem is there now. That one problem I have done here now. Understand now. And next question I will give. You try to tackle this question. One more question I want to give here now. From the extrinsic semiconductor, certain gate questions are there, I will give. From extrinsic semiconductor. An N-type semiconductor, the problem is given like this. An N-type semiconductor, this is a gate question. An N-type semiconductor, an N-type semiconductor has the following data. The whole electron mobility ratio, whole electron mobility ratio is given in this question. Ratio. That ratio is given 0.4. It's given 0.4. It doesn't have any units. The ratio only. Next, intrinsic concentration Ni is given. Ni is given as a 1.5 into 1.5 yes, for data is the 0.4 doping one more doping concentration, not Ni, doping concentration is given still it is given, and that ratio is given 0.4, and also it is given doping concentration. Doping concentration is given. The doping concentration is 4.2 into 10 power 8 atoms per 4.2 into 10 power 8 atoms per meter cube is given. Per meter cube only given. Per meter cube is given. And intrinsic concentration is given here now. Ni. Ni also given in this problem. Ni is nothing but 1.5 into 10 power 4. 1.5 into 10 power 4 per meter cube is given. Per meter cube. The ratio of here required the ratio of conductivity of N-type sample to N-type sample to intrinsic sample will be dash. This is one of the gate question, but anybody can do without my help. I want to give you some time. Please start doing this question. I wish to know how many students can do this question. This is the given problem. This is one of the gate problem. I think you will give answer very easily. Any student can give? Yes, I'll do here, please watch. An N-type silicon has the following data. The given material is N-type extrinsic semiconductor. Here given whole electron mobility ratio 0.4. Whole electron mobility ratio means mobility of mu p by mu n is given. This is equal to 0.4. Whole mobility divided by mobility of electrons given 0.4. Doping concentration is 4.2 into 10 power 8 atoms per meter cube. Doping concentration is a pentavalent atom or trivalent atom? Just to check it. In the problem it is clearly given N-type semiconductor. N-type semiconductor means it is doped with pentavalent atom only now. So I can take this doping concentration with a name of Nd, donor concentration. So I can write Nd is nothing but 4.2 into 10 power 8 per meter cube is given. Atoms per meter cube is now. Intrinsic concentration anyhow given here now. Is asking to find the ratio of conductivity of N-type sigma N to the intrinsic sample will be conductivity of intrinsic sample sigma I. This ratio is required. Sigma N by sigma I is required. Sigma N is nothing but you know very well. Here the sigma N is nothing but Nd into donor concentration to Q into mu N, you know very well. Nd into Q into mu N is nothing but the sigma N. In many questions I did. Sigma I you know very well. Sigma I is nothing but, what is sigma I? Ni into Q into mu N plus mu P. You know very well. Already derived this formula. Thereby cancel Q and Q. Q and Q can be cancelled. Thereby, there in the problem it is given mu P by mu N is given. So divide in the numerator and denominator by mu N. If I divide it by Q also cancel now. I can write Nd into mu N by mu N 1 Ni, the Q value will be cancelled. But a mu N divided by 1 plus mu P by mu N you will get. Mu P by mu N you can get here now. There you can substitute. Nd we got as a what? Nd is nothing but 4.2 into 10 power 8 given in the problem. And Ni also given in the problem. Ni is nothing but 1.5 into 10 power 4 is given. 10 power 4 is given here now. And 1 plus mu P by mu N is given. Mu P by mu N means mu P by mu N equal to 0.4. You know very well. 0.4. 1 plus this value. 1 plus mu P by mu P. Ni is a 1.5 into 10 power. This is the value is possible here now. 0.4. And use the calculator. You are going to get finally sigma N by sigma I you will get here now. That value is 20,000 it comes. 20,000 it comes. The solution of this question 20,000 is possible. This is one of the gate question I say. 4.2 into 10 power 8 by 1.5 into 10 power 4. Yes, this is the way we can tackle this question. I hope you followed. And I want to give one more question here now. Before going to the next question, I would like to give some information regarding the graded semiconductor. Some information required. Graded semiconductor. Next question. To do the next problem, this information will be useful. Graded semiconductor. Semiconductor. Already we discussed compensated semiconductor. This is nothing but the graded semiconductor. How to define graded semiconductor? Suppose I selected here intrinsic semiconductor. I selected one intrinsic semiconductor. The intrinsic semiconductor is not doped uniformly. Uniformly not doped. That means here the doping is made improper manner now. One side higher concentration, other side lower concentration, difference of the concentration it is existing only now. If there is difference of the concentration in this material, then we can call it as a graded semiconductor. What I said, If intrinsic semiconductor is not doped uniformly, then it is said to be graded semiconductor. Only one definition I can give like this now. If intrinsic semiconductor is not doped uniformly, it is not doped uniformly. One side higher concentration, other side lower concentration, it can exist. Not doped uniformly, then it is called as graded semiconductor. Graded semiconductor, I can say. This is the information more important. Sir, why do you explain this graded semiconductor? In the graded semiconductor, one mechanism is possible. That mechanism is nothing but the diffusion. So I need to give definition for the diffusion. Then after we can do problem solving now. So here required diffusion. How to define diffusion? There is a graded semiconductor. This I want to take it as a graded semiconductor. In this graded semiconductor, we don't find the addition of the impurity uniformly. One side you can find the higher concentration, maybe electrons or maybe holes possible now. The other side it is existing lower concentration only. One side higher concentration, other side lower concentration. Initially I have taken electrons one side higher, electrons other side lower. Otherwise you can take holes also in the material. Maybe electrons, maybe holes also possible. Suppose the holes are trivalent atom is doped. At the time you can find majority carriers of the holes here like this now. Holes are going to exist. One side higher concentration of the holes, other side you can find the lower concentration of the holes. This is for electrons, this is for holes. When there is difference of the concentration in the material, what is going to happen? When there is difference of the concentration between any 2 points, then what is going to take place? The charge carriers are going to move from higher concentration to lower concentration. This is a higher concentration, this is nothing but a lower concentration, higher and lower. That means that these are all the charge carriers are going to move this side to this side. Higher to lower, the charges, these are the charge carriers are going to move. The movement of charge carriers from higher concentration to lower concentration is called as diffusion, we can define. So, we can write the movement of charge carriers from higher concentration to lower concentration, lower concentration is called diffusion, I can say, is called diffusion. This is only diffusion only. The movement of the charge carriers from higher concentration to lower concentration is called as a diffusion only now. But here we can create one formula here now. Current density, because when the charge carriers are moving in this graded semiconductor, current density is going to exist. But how to find out the current density? Current density due to holes I have taken for example. Current density due to holes is directly proportional to charge into gradient possible. Charge into gradient. Gradient means slope, you know very well. Gradient. This is nothing but the distance x for the holes. This side we are finding the concentration of the holes. This axis, y-axis is holes. This is the x is the distance. So J suffix P is nothing but current density due to holes is directly proportional to charge is Q. Gradient is taken slope. Slope is nothing but dP by dx only. Dou P by dx, dou x or dP by dx allowed. dP by dx we can write here now. And a Jp equal to J suffix P, current density due to holes is equal to proportionality constant is possible here now. That proportionality constant is taken as a minus dP into Q into dP by dx. So this is the formula is taken for current density in the graded semiconductor. This is happened when there is diffusion in the material, where dP is given a name, where dP equal to coefficient of diffusion, coefficient of diffusion we can put, diffusion I can put now, coefficient of diffusion only now, coefficient of diffusion they will put dP. But why we are putting minus sign? Because of the diffusion, what is going to happen, the charge carriers are moving from higher concentration to lower concentration. But due to this mechanism, here initially higher concentration is existing. Slowly this concentration is going to decrease. The decrease of the concentration at higher, at initial place only now. That means the decrease of the concentration at this position is what is taken as a minus. Minus indicates decrease of the charge carriers only, where at higher concentration, initially with a higher concentration, but because the diffusion concentration is slowly decreasing only now. That's why it is given with minus sign only now, understand now. But this is the current density, dP, but the current density in this graded semiconductor. Similarly, for the electrons, how we can write the formula? For electrons, we can write formula like this. For electrons, Jn equal to, we can write Jn equal to dN into Q into dN by dx, they will write. We cannot find here minus. This can be taken with a positive value only. Here already minus is there now. It becomes a plus. Why it becomes a plus? The Q is nothing but the charge. Charge of electron is a minus 1.6 into 10 power minus 19 exactly. For electron minus, minus into this minus becomes a plus value. There's a why we are getting Jn with a plus means because the product of the minus and minus 1.6 into 10 power minus onwards, 1 minus you are getting. That minus minus becomes a plus only now. Like that, we can get the value only now. Understand my point now. Now, I will give one problem based upon this diffusion. You will get idea clearly now. And one more formula also very important. Now, Einstein relation also very important. After that, I will give the problem. Einstein relationship. EIN STEIN. Einstein's relation. What is that Einstein relation? But Einstein gave one relationship between coefficient of diffusion or diffusion, we can say coefficient of diffusion, mobility. That means he gave, I will give clearly now, diffusion and mobility. Diffusion and mobility. Diffusion and mobility are related related are related to each other, related to each other, each other. I will explain. Related to each other through Einstein relation. Einstein relation, the relation. But that means diffusion and mobility are related by the Einstein relation, it says. What is that? That means that diffusion means, you know very well, dN by mobility is nothing but the mu n. dN by mu n, otherwise you can take dP by mu p also acceptable, or dP by mu p is equal to thermal equivalent of the voltage only now. The relationship is given by the Einstein. Diffusion to the mobility is equal to thermal equivalent of the voltage. Vt equal to the thermal equivalent of the voltage. But a thermal equivalent of the voltage is nothing but where Vt equal to, I can write thermal voltage. It is said to be thermal voltage or thermal equivalent of voltage. This is taken as a thermal voltage. This thermal voltage is equal to how much? 26 millivolts. Generally we are going to use 26 millivolts. It is taken at room temperature. At room temperature it is given. At room temperature generally you will put now. Around 300 Kelvin you will get 26 millivolts only now. But suppose any other temperature is given, means how we can find thermal equivalent of voltage R? It is not given. What now? Room temperature is a 400 Kelvin or 600 Kelvin, something it is given. In that case, in general, thermal equivalent of the voltage is calculated by T in Kelvin only, not in centigrade. That point is very important. The T is always taken with Kelvin by 11,600. 11,600. By using this formula for any temperature, you can determine thermal equivalent of the voltage only. Understand my point now? So this is Einstein relation. Understand now? So every formula I gave it here now. And next one is before the completion of this part, I would like to give some information regarding the IMS GATE Academy here now. The students who wish to take admission for GATE 2025 and 26, they need to call to this number. You call to this number and get information from IMS GATE Academy. That means if the student, you can take the admission in IMS GATE Academy. But if the students, that means if the student is willing to take an admission in IMS GATE Academy, he has to understand what are the benefits are possible here now. So the program features of the IMS GATE Academy I will give. From that you can understand what benefits you can get if you have taken admission in IMS GATE Academy. The more than 800 hours of the live classes with the live interactions possible now. IMS GATE Academy provides theory book, exercise books. The exercise book contains more than 4,000 questions. It contains level 1, level 2, level 3 questions. But these are all the questions are more than 4,000. Next one, more than 34 years GATE question banks with video solutions possible. And also 12 personalized one-to-one mentorship sessions possible. More than 130 online tests with video solutions of the mock tests and many more possible. Don't delay. Take an admission in IMS GATE Academy. But every faculty having more than 10 years experience. They are ready to give good subject to the students now. Once to take the admission and get benefited. Understand now? I think so far you followed very well about the subject. Thank you all.